Good evening. So in the last class we have started recording coordinate geometry. Today I am going to continue few questions with the usage of the distance formula. If possible, I will start today's section 4 because the book what I am having now here, I don't have much more problems. Will continue in next sessions. Okay. If possible, I'll start. Otherwise, I'll continue the distance formula application only. Yes, last class we have proved, yes, they are the vertices of a rhombus showing adjacent sides are equal, diagonals not equal. And also we calculated the area of the rhombus using the formula half into d1 into d2. Now again I'll go back to find the point on the x-axis, point on the y-axis where we can obtain the order pair, the value of x. 1 second. Yes, we'll have the question. If possible, I will. When I dictate, you can take it, or else okay. Find the values of x. Yes, find the values of x for which the distance between the point P 2, 3. Here they have given P and Q with their order pairs 2, -3 and x, 5 with 10 units distance. Usually when the order pairs of the points given, we calculate the distance between the 2 points, right? Now they are given the distance. Here it is x1, y1, x2, y2. Where x2 is unknown, that unknown we have to calculate. Is it clear? The mode of asking the question here is different. You have to find the value of x such that distance between the point PQ is 10 units. Now let us use the distance formula. PQ equals root of x2 minus x1 whole square y2 minus y1 whole square. Now the distance PQ is 10, whole square means the root will get cancelled in the RHS. Now we have x1, y1, x2, y2. You will get x minus 2 whole square, 5 plus 3 whole square. Y plus 3, 5 minus of minus plus 3. Okay, na? So 10 square is 100. X square minus 2ab plus b square plus 64. 5 plus 3, 8. 8 square is 64. Now, x square minus 4x plus 68 minus 100 equal to 0. I transferred 100 to RHS. Now, the equation becomes x square minus 4x minus what you get? 32 equals 0. Now factorize, you will get two factors. Those two values are the position of the point x2 value. How to factorize this? 8 4s are 32. X square minus 8x plus 4x minus 32 equals 0. Now taking x common, what we get? X into x minus 8, 4 into x minus 8 equals 0. So x equals 8, x equals minus 4 are the solutions. Find the values in the question itself. They have given values that shows that you will get two values for x. It satisfies. You can check it. Taking x2 as 8, you find the distance 10. Taking x2 as minus 4, you find the distance 10. That gives the verification of your answer. The use the distance formula here. When we square it, the root will get cancelled. We have x2 minus x1, y2 minus y. I hope that it is clear to everybody. Yes. Give up your answer. At least 50% are present. I need 50%, that is 34 students here. I want the answers individually. Yes, Vishal, what is the answer? You have not mentioned the answer. Okay. Shall I move on to the next question? Yes. Next question. Like yesterday's problem, here you have to find out the relation, that is in terms of x and y. Find relation between x and y such that point P x comma y, this is point P x comma y, is equidistant from the point 3 comma 6 and minus 3 comma 4. Equidistant. When it is equidistant, what condition we have to take? Equidistant. Point P has the order pair x comma y. We have to make a relation such that they are equidistant. When it is equidistant, we consider PA equals PB is given. Okay, now which implies PA square equals PB square. Now PA, what you'll get? You can take like this also, x or 3 minus x minus 3. What will get? X minus 3 whole square, y minus 6 whole square equals x plus 3 whole square, y minus 4 whole square. X2 minus x1, minus of minus, it becomes plus. Y2 minus y1, x2 minus x1, y2 minus y1. Clear? Now start expanding it. You will get x square minus 6x plus 9. A square minus 2ab, 2 into x into 3 plus y square minus 12y plus 36 equals x square plus 6x plus 9 y square minus 8y plus 60. Check it once. A square minus 2ab plus b square. A square minus 2ab plus b square. Orally you can do the product. If not, show that 2 into a into b, you can do the multiplication in the next step. So what is the next step here? What is the next step here? What we can do? We can cancel x square, y square from LHS and RHS. Check out any number here. 9 is there. That will cancel. That's all. I will transfer this. Before that I will write 6x minus 12y plus 36 equals 6x minus 8y plus 60. Yes, cancelling LHS and RHS part. Now transfer, it becomes minus 12x minus 4y equals minus 20. Correct? Minus 12x minus 4y minus 20. So now the common factor is minus 4. What you will get? 3x plus y equals 5. Check your answer. 3x plus y equals 5. Yes? Have you all got the answer? Yes. Shall I proceed? Next question. Show that the points, this is also one of the application question. The questions what I am doing now, all these are board appeared questions. Show that the points, take the points on an equilateral triangle ABC. Show that the points A comma A minus A comma minus A and minus root 3a comma root 3a are the vertices of an equilateral triangle. To show they are the vertices of an equilateral triangle, we had to find out AB distance, BC distance, CA distance. If all the three measurements or the distance are same, then we come to the conclusion, yes, they are the vertices of a triangle. Okay, na? So now let us find out AB distance, keeping root as it is, root of A plus A whole square, A plus A whole square, x2 minus x1, minus of minus is plus, y2 minus y1, A plus A. What you will get? A plus A, 2A. 2A whole square means 4A square plus 4A square. It is root 8A square. So we can take it as 2 root 2 A units. Can we take like this? Is it clear? A plus A, 2A. 2A whole square is 4A square plus 4A square. You will get 8A square. You cannot take 4 as 2, 2 plus 2, 4A. Okay, na? Under root 8A square, you can write root 8 as 4 2s are 2 root. Root A square is A. Clear? Is it clear? Yes. Now let us find out BC distance. Here x1, y1, x2, y2. What you will get? Root 3a plus a whole square root 3a plus a whole square. I can take it as a minus root 3a whole square, a plus root 3a whole square. So in order to keep in order, I took like this. Now a square plus b square, a plus b whole square minus 2ab you can do, or else separately you expand and then take it out from the root. If you have the doubt, you can see the working. Okay, what you will get? A square plus b square minus 2a square into root 3. A square plus b square minus 2ab, correct? Plus a square plus b square plus 2ab. So this will get cancelled. What we get? Root of 4a square plus 4a square, 8a square. Further we can write it as 2 root 2a units. That is BC. Next, CAC. Same condition. Root of a plus root 3a whole square, a minus root 3a whole square. Just what we did here also on expanding. Final answer is 2 root 2a. You will get a square plus b square plus 2ab, a square plus b square minus 2ab. Cancel. A square plus 3a square, 4a square plus 4a square, root of 8a square. Further it is 2 root 2a units. Then how will you conclude? Since AB equals BC equals CA, therefore they are the vertices of an equilateral triangle. Yes, do the expansion properly and then conclude your answer. Yes, they are the vertices of an equilateral triangle. Okay? Yes. Since all the three sides are equal, they form the vertices of an equilateral triangle. Is it clear to everybody? Yes. Next question. Find the point on the x-axis. Next question. Find the point on x-axis. When it is point on x-axis, we consider its order pair as find the point on x-axis. That means P, what we can write? Find the points on x-axis P, x, comma 0. Very good. Find the points on x-axis which are at a distance of 2 root 5 from the point. It's not given, only the point P, which is at a distance of 2 root 5 from the points 7 comma minus 4. This is the condition. That means if you have x value 2 zeros, 2 values, then 2 comma 0, 3 comma 0, like that you have to mention. Find the points on the x-axis which are at a distance of 2 root 5 from the point 7 comma minus 4. The condition is let p x comma 0 be a point on x-axis. Okay, therefore PA equals root of x2 minus x1 whole square y2 minus y1 whole square. Okay, so then when we square, that PA is 2 root 5 whole square equals x minus 7 whole square 0 plus 4 whole square. x2 minus x1 whole square y2 minus y1. Minus of minus, it becomes plus. Now 2 square is 4, root 5 square is 5, 4 5s are 20 equals x square minus 14x plus 49 plus 16. Now x square minus 14x plus 65 minus 20 equals 0. Clear? Next, x square minus 14x plus 65 minus 20 is 45 equal to 0. Now factors, how can we write here? X square minus 9x minus 4x plus 45 equals 0. So what is x? X minus 9, 4, x minus 9. So the values of x are x equals 9, x equals 4. These are the points. So they are asking what are the points? P 9 comma 0, P 4 comma 0 are points on the x-axis which are equidistant, which are at a distance of 2 root 5 units from the point 7 comma minus 4. So try to understand the concept here given. Which are the values which is 2 root 5 distance from the point A 7 comma minus 4. Minus 14 can be taken as minus 9x minus 4x. 9 4s I did. 9 5s, I'm sorry. So the points are, thank you Vagdevi, 9 5s. So x equals 9, x equals 5. The points are 9 comma 0 and 5 comma 0. Okay, now next question. Yes, Prarthana, you are right. In JSS, the coordinate geometry they have completed. In JSS Public School, have they completed coordinate geometry? And which other school has done this chapter, coordinate geometry? No. Then which school have done coordinate geometry? No school. Okay, in DMS they have done. Nice. I thought that this will be a easier chapter. So with this type of this you can easily manage to go through this, and some schools are having the exams. Even later if they observe the recorded, they could do go with this. Okay, na? Next question. Now it is clear to everybody how we can apply distance formula to find the distance, to find the unknown coordinates, to verify they are the vertices of a right isosceles triangle, the type of the triangle, the opposite sides are equal, you can verify, adjacent sides are equal and diagonals are not equal. All these verifications of the properties of the plane figure we can go with this. Okay, na? Next question. Points A 5 comma 1, B x comma 7, C 8 comma 2. Points 5 1 x 7 8 2 or 3 points such that AB equals 2AC, find x. They have given the relation of the segment part, that is distance AB is 2 times the distance AC, or you can take AC is half of AB. On such condition, what is the value of this x? Okay, let us find out first what is AB. Using distance formula, root of x2 minus x1 whole square, y2 minus y1 whole square. Distance AB equals root of, this is x1, y1, x2, y2. So x minus 5 whole square, 7 minus 1 whole square, x2 minus x1, y2 minus y1. What you will get? Root of x square minus 10x plus 25 plus 36. X square minus 10x plus 25 plus 36. Further we can write it as x square minus 10x plus 61. This is AB distance. Let us calculate AC. Using distance formula, we have AC 8 minus 5 whole square, 2 minus 1 whole square. It is root of 8 minus 5 is 3, 3 square is 9 plus 1, it is root 10. Now the condition AB equals to AC. What is AB here? Root of x square minus 10x plus 61 equals 2 into root 10. AC is root 10. So in order to take off the square root, We square it on both the side. Therefore, x square minus 10x plus 61. When I square, that whole square in this root will get cancelled. Now 2 will become 2 square. Root 10 will become 10. Is clear? Root 10 whole square. 2 square is 4. Root 10 square is 10. Now what you get? X square minus 10x plus 61 minus 40 equals 0. Next, x square minus 10x plus 21 equals 0. Next, x square minus 7x minus 3x plus 21 equals 0. So, x into x minus 7, 3 into x minus 7. You will get x equals 7, x equals 3. Both will satisfy. 7 minus 3 and 7 will satisfy the condition, that is distance AB is 2 times distance AC. And that condition we can say C is the midpoint of AB because AC is half of AB. They can show. Even that will also satisfy using this distance formula without actually locating these points and measuring and finding what value of x will satisfy. Using distance formula we could apply the condition. Is clear? Check it once.
ದೊಡ್ಡ ಧರ್ಮ ಡ್ಯೂಮ್ ಅಂತ ಗೊತ್ತಾಯಿಲ್ಲ. ಧರ್ಮ ಡ್ಯೂಮ್ ಅಲ್ಲ, ಧರ್ಮ ಡ್ಯೂಮ್ ಇದಾ. ಥ್ಯಾಂಕ್ ಯು.
Have you all got the answer? Yes? Next question. Another question, application of again the distance formula. Like in AP we have distance formula, nth term of an AP, sum of n terms of an AP, like that. In coordinate geometry you have distance formula, section formula. They have taken off area formula application. Only 2 application for this chapter, coordinate geometry. Okay? Yes. Find the point on S, point of, find the value of F if the point P, if the point P 0, 2 is equidistant from 3, S and 5, 3. 3, S and 5, 3, I think it is 3. I will check it once. So get the figure. Before that, I'll check the question whether it is 3 or 5. Yes, it is 3 comma yes and 5 comma 5. It's not 3. It is 5 comma 5. Condition point P 0 comma 2 is equidistant from point Q and R. So now we have the condition PQ equals PR as given condition, which implies PQ square equals, such type of question we have answered in the previous class only. We have PQ square equals PR square, so that without using square we can apply distance formula. X1, Y1, X2, Y2. 0 minus 3 whole square, 2 minus S whole square, 5 minus 0 whole square, 5 plus 2 whole square. In both the side I have taken off the square root because we have taken the distance as PQ square equals PR square. Now start expanding it. 3 square is 9. A square minus 2AB plus B square equals 25 plus 49. I'm right? 25, 5 square, 49, 7 square. Now we have 9 plus 4, 14 minus 4s plus s square equals 25 plus 49. Therefore, s square minus 4s plus 14 minus, what you will get? 74 equals 0. S square minus 4s minus 60 equals 0. Now get the factors of this quadratic form. What you get? S square minus 10s plus 6s minus 60 equals 0. Taking s common, s minus 10, 6 common, s minus 10 equals 0, s equals 10, s equals minus 6. Both will satisfy. Check out. You can leisurely check out by keeping the values of s and check whether they are equidistant from the point P 0 comma 2. Okay, have you all got the answers? Next question. Shall I move on to the next question? it is given, show that point P is the center of the circle circumscribing a triangle whose angular points. This is the figure we have to proceed. This is circumcircle circumscribed by a triangle. We have to prove point P 1 comma minus 1 is the center of the circle whose vertices are 4 comma 3, B minus 2 comma 3, C 6 comma minus 1. That means, I will read out the question once again. Show that point P 1 comma minus 1 is the center of the circle circumscribing the triangle whose angular points are the given. So how to verify? Yes, point P is the center of the circle. What is the condition required to show point P is the center of the circle? How can we verify? How can we check? Yes, come on. If point P is center of the circle, what condition is satisfied? Yes, very good. It should satisfy PA equals PB equals PC. If they are equidistant from the center, then we can say that P is the center of the circle. Come on, check it. We have to check the distance to PA. For distance to PA, we have root of PA x1 minus x2 whole square, y1 minus y2 whole square, 4 minus 3, 3 square is 9, 3 plus 1, 4, 4 square is 16, it is root 25, answer is 5 units. Similarly, calculate PB root of 6 minus 1 whole square minus 1 plus 1 whole square. Y2 minus 1 minus of minus, what you get? Root of 6 minus 1, 5 square is 25 plus 0. Its answer is again 5 units. Then calculate PC root of, I did now PC only, I think. PB you have to do. Please check it. PC I have shown. Now PB, what you will get? 1 plus 2 whole square plus minus 1 minus 3 whole square. x2 minus x1, or you can take from here also. In both the cases, you will get the same answer. So what you will get? 1 plus 3, 1 plus 2, 3 square is 9, minus 4 square is 16, it is root 25. Finally, this is also 5 units. After getting the distance from point P to A, P to B, P to C, then your conclusion, since PA equals PB equals PC, therefore point P 1 comma 1 is the center of the circle. Conclude your answer, center of the circle. Yes, each distance we are getting 5 units. Even the values are different. Final simplification it is 5. Whether you can take it from here to here, here to here, you can check it. You will get in all the cases whether it is x1 minus x2 or x2 minus x1. The distance, if it is equal, it shows all the distance as same answer. Then we have the conclusion. Yes, P is the center of the circle. Okay. So many problems you have worked out with the application of distance formula. Again, we'll get a few more questions. Now I'll move on to the second version of this chapter is usage of section formula. So I will show you how it differs from distance formula. What is the importance of this section formula? How we can verify some of the conditions using this section formula also. Okay, now you all taken this? It's clear to everybody? Okay. Next question. Section formula. Don't write anything now. Second formula is section formula. In this section formula, the section itself shows that it is bisecting in different ratio or in same ratio. Then how to obtain the ratio? When we know the ratio, how to find out the coordinates which is unknown. All those concepts you are going to study here. Okay, let us consider a line segment AB with x1, y1 order pair, x2, y2 order pair is bisected by another line at point P, x comma y in the ratio m is to n. Don't write anything now. Listen the explanation. I'll give the notes. Okay. AB is a line segment with the order pair A x1 y1 B x2 y2 is bisected or make a section over AB at point P whose order pair is x comma y. Then with the ratio m and n, m1 m2 or m1 I will take m1 m2, then this value x can be taken as m1 x2 plus m2 x1 by m1 plus m2. When we know this, you can find out any one of this. When we know the ratio, you can find out this value. That is, x value can be taken as m1 x2 m2 x1 m1 plus m2, where y equals m1 y2 plus m2 y1 by m1 plus m2. This we call it as section formula. Suppose if instead of intersecting AB at any point. Suppose if a point divides AB in the same ratio 1:1, that means P is the midpoint of AB. Then we can find out x equals m1 plus m2 by 2, y equals m1 m1 x2 is 1. I'm sorry. The ratio is 1:1. Therefore, x equals x1 plus x2 by 2 and y equals y1 plus y2 by 2. This is the improved version of this section formula. When a line segment is bisected in the ratio m1 m2 ratio, then we can find the values of x and y using this. Suppose the same point divides AB in the ratio 1:1, then we can use this formula. We call this formula as midpoint formula. It's not theorem, midpoint formula. So please take it down. Before that, I'll dictate statement. You take the statement. Let AB is a line segment. Let AB is a line segment such that A x1 y1, B x2 y2, intersected by the line at point P x comma y in the ratio m1 and m2, then using section formula, the values x and y can be calculated as please take down the first two formula. X equals m1 x2 plus m2 x1 by m1 plus m2. Y equals m1 y2 plus m2 y1 by m1 plus m2. Underline it. Next, second point. Suppose if a line segment AB is intersected by a point, P x comma y in the ratio 1:1. That is bracket. That is P is the midpoint. That is P is the midpoint. Then we calculate the values of x and y, using midpoint formula, as take this formula with the figure. After that, you take this figure. Third case. In the third case, shall I rub this? Take the figure of this third case. Here point P x comma y divides AB in the ratio k:1. Ratio is not known. k:1. Let P x comma y divides AB in the ratio k:1, then x equals kx2 plus x1 by k plus 1, y equals ky2 plus y1 by k plus 1. That is, when ratio is not known, then we can use this formula to find its ratio. In what ratio it is divisible by the point P? In such case, point on x-axis, point on y-axis. Then we use this formula, K formula, midpoint formula, section formula. When the ratio is known directly, you can find out the order. When it is in the ratio 1:1, you can directly apply midpoint formula. When the ratio is not known, then assuming that it is dividing AB in the ratio k:1, on what ratio it is dividing and at what point the AB is intersected at point P, the order pair, you can easily calculate. This is the application of section formula 1, direct formula, then midpoint formula, then K formula. Okay, based on this you will have the problems in tomorrow's class. Point is at the origin, you have one more formula, root of x square plus y square. Now this section formula, when a point P divides a line segment in the ratio m1 and m2, we have midpoint formula when a point P is dividing the ratio of AB line segment in the ratio 1:1, and also we have K formula where the point P divides AB in the ratio k:1. In the next class, we will have this application on what condition we could apply either section formula or midpoint formula or K formula. Okay, na? So recall these formulas. We'll have the class tomorrow. Okay. Thank you, children. We'll see you in the next class.